Good morning and welcome to week 2 of electricity. We're going to be doing series and parallel circuits this week on the 2 different days. So I split it up so that it shouldn't be too much each day. Okay, so we're going to start with series circuits. So here's a warm-up, good practice problem. So go ahead and try this one on your own. Hopefully you identified just your basic equation. Velocity is equal to current times resistance. Plug in the values that you know and solve for the current that you don't know. Okay, our first circuit is the series circuit, and it's the most straightforward because it looks like a circle. Everything just goes around one single path. So, a series circuit is when electrical devices are connected end to end. Each one is connected to the next, and they just kind of make one single loop. So here's a real basic series circuit. You got your battery right here on the left, and then in this one, we just have 3 resistors. Those 3 resistors could be anything. Right now, they're just resistors to show you something, but they could be light bulbs, they could be motors, they could be TV screens, LED screens. They could be all kinds of stuff, buzzers, horns, whatever. But right now they're just resistors because that's just the easiest thing to use. Please note that the current is drawn on here and it flows like this in a clockwise fashion because the positive end is on this side, so it goes positive around to the negative. So a couple things. One, since it's one single path and everything's connected, the current is going to be constant. The current is going to be the same at every single spot through every single device in a series circuit. And the voltage drops add up to the total voltage. So what that means is however much voltage each of these devices is using is going to add up to how much this battery is supplying. So just real basic, if this is a 24-volt battery, and let's say all 3 of these are the same size, then all 3 of them are going to be using 8 volts. So 8, 8, 8 would be 24 volts. And then the last thing is that the total resistance in the circuit is the sum of all of the different resistors. So if each of these was 4 ohms, it'd be 4, 4, and 4. So you'd have a total of 12 ohms of resistance in this circuit. So the total resistance is just the sum or adding up all of the resistors in the circuit. Like I said, series is the most straightforward. It makes the most sense. It's the easiest one to do. Parallels, a little bit different. It's not real hard, but it's just a little different. So let's do an example problem. So a circuit consists of 3 resistors connected in series to a 24-volt battery. The current in the circuit is 0.032 amps. Given those resistors, what is the missing resistor's value and what is the potential difference across the resistor? So first we kind of ask ourselves a couple things. Potential difference, hopefully you remember what that was from last lesson. Potential difference is just the voltage. In this case, how it says across the resistor, so how much voltage is that resistor using? So just like with all the other things we've done all the way in the past, always draw a picture first. So we get our picture here. It says it's a series circuit, so we draw a little circuit, and we know everything's in series, and we know there's 3 resistors, so we got our battery and 3. Always draw a picture of your current so you know which way everything's flowing, and we label everything. So we gotta ask yourself, okay, what do we know? Well, if we start with our total, remember this V equals IR, that V equals IR can be used for anything. It can be used for the complete circuit, or it can be used for each individual device in the circuit. So if we look at it as a whole, if we know the total voltage, which was 24 volts, and if we know the total current, which was given to us, we can find out what the total resistance is. So if we plug those things in, we can find out what the total resistance in the circuit is, which turns out to be 750 ohms. And because we know that all of the resistors simply add up to the total, well, then we can just go up here. Our total is just the sum of all of them. So we can plug everything in and solve for that missing third one. So we find out that our missing third one is 350 ohms. So that's part A. Part B says, what's the potential difference across the resistor? So what is the voltage that's being used by that third resistor? Well, first thing we want to do is we want to figure out how much voltage is being used by this one here. And we can find out that that's 8 volts. Then we can find out how much is being used by this one. All right. And there's a couple different ways that we can do this. And this is one of the nice things about circuits, is because there's several different ways to do it. And there's also a double check. So we could just subtract or add these two together and subtract it from our total, and that would tell us what our third one is. But since we found out resistance and we know that current is constant, then we can plug it in and we can figure out that it should be 11.2. Now, like I said, there's always a double check. So after you do all this, it's always best to check your answer. And because we know that all of the voltages have to add up to our total, and if we add up all of these voltages, we get 24 volts. So that tells us we did it, we probably did everything right. Okay, here's one for you to try. So this circuit consists of a 12-volt battery connected to 3 resistors in series. Make a sketch, find the current, and find the voltage across each resistor. So go ahead and give that a try. Hopefully your sketch looks something like this. This is your battery, and it's also your total voltage. Make sure you make one line a little bit longer, one a little shorter. The positive side is your longer side, and current flows from that positive side to the negative side. So we got resistor 1, resistor 2, resistor 3, and I labeled them with those 3 resistors, or those 3 resistor values. And our total resistance is just adding them all up. So since we already know that, it's kind of like the first thing you do is add them all up. Then we use our V equals IR equation, and this is just that same equation, just rearranged. And once we do that, then we know our total current. And for a series circuit, that's really important because that is the constant current through the whole thing. So that is the current going through each device. So from there, we use our V equals IR equation for each of the 3 resistors. So our constant current is right here, our 0.071, that's our constant current. And then we have our 3 resistors, multiply them together, and we get the voltage that each one is using. And like I said, always double check, add them all up, and make sure that they all add up to the original, which is 12 volts. Go back up and check, and sure enough, 12 volts. So that's it. The series circuits worksheet should be up on Classroom, so go ahead and work on that. And next time we will do parallel circuits.